0. Shout out today from the pre-calculus class to Courtney and Bryant and anybody else who missed. The keyword is...
No, we should put it at the end.
Oh, yeah. Well, we're putting it at the end.
Or they don't know where we're going to...
Actually, you don't know where we're going to put it. Otherwise, you just be able to fast forward forever. So there's going to be a key word. If you watch a video, you might get yourself a treat in the process, okay? All right, so on your worksheet right now, we are on the reference angles and coterminal angles worksheet, okay? And on that worksheet at the top, it says the following. It says reference angle, and a reference angle is the acute angle formed with the x-axis. It's the acute angle formed with the x-axis. So yesterday we practiced a lot of converting radians to degrees and things of that nature, back and forth, which was good. You guys learned to sketch angles. Well, now if you sketch an angle, angles have different properties about them, and one is called a reference angle. So there's 4 options. I think you have this little diagram on your worksheet, don't you? There's 4 options. You could get an angle in the first quadrant. You could get an angle that's in the second quadrant, an angle in the third, or an angle in the fourth quadrant. You guys find where we're at? And if we're talking about the reference angle, we're talking about this angle. It's an acute angle, meaning an angle between 0 and 90 degrees, and it's always against the x-axis. So the green angle right here, notice that that is far bigger than 90 degrees, but its reference angle is the angle that's formed against the x-axis. Sometimes people get kind of cute and they try to switch things up and they say, oh, well, the angle is, it looks like it's kind of up against the y-axis. Absolutely not. It is always formed right against the x-axis. And then here as well against the x-axis. So those are the angles that you'll be trying to determine. Those will be the angles that you'll be trying to determine.
Does that symbol stand for angle?
Yes, theta. Sorry, did I not say that yesterday? So theta is it's the variable, kind of like x or y, that is used to represent angle measurement. It's spelled, so it's the Greek letter for th, so we spell it like that, theta. The actual Greek spelling is, that's a theta, that's an eta, this is tau, and that's alpha. Looks like that, theta. There you go. Or like Lily, we could do. There you go, Lily. There's your name.
It's beautiful.
You like that?
Yep.
All right, good. There's your little Greek lesson for the day. And what do we have? We have 2 angles. Is the first one give you 255? 215. So 215 degrees. The question is, what is the reference angle formed for 215 degrees? Which quadrant is 215 in? It is in the third quadrant. And so what you're looking for, what you need to be able to work through, is if this is a 180 degree measurement and this is a 215 degree measurement, we want to be able to find that angle. So how far past 180 is 215?
35.
Just 35 degrees. So that's your answer, 35 degree measurement. That's the reference angle. And before I start have you working on your assignment, we'll come back to the other one, we're going to have you guys look at the next one. Is the next one 5 pi over 3?
Yeah.
So 5 pi over 3. And if you recall, this is pi, and this is 2 pi. Anybody know what 5 pi over 3 is in degrees? It is 300 degrees, so that would be in the fourth quadrant, okay?
How do you know it's 300?
So we take 5 pi over 3 and we multiply by 180 over pi. So the pi's cancel. So I think Brecken saw that since it's pi over 3, that's 60, and 60 times 5 is 300. Okay, and so you can see that then you have 360 degrees, and so therefore the reference angle is this angle right here, 300 to 360. That's going to be a 60-degree angle, 60 degrees. Now, as it's expressed in radians, you could express it in radians if you so chose. A lot of people kind of get confused by that. If you just have 5 pi over 3 and 360 is 6 pi over 3, you can see that 60 is the same as pi over 3. So you should always be able to convert back between degrees and radians. I think I express the answers. If it's in radians, I express the answer in radians on the worksheet. You can go ahead and express it in degrees, that's fine. So looking at your worksheet, you have problems 1 through 20 there. You're going to take about 7 minutes right now, and you're going to focus on finding those reference angles on your worksheet. So go ahead and take some time. I have the answer key posted right here. After 7 minutes, we're going to go to the priority of our lesson today. Okay? Go ahead and take some time at work. And this is a great time to plant our secret word. Secret word, people, is jellyfish. There you go, jellyfish. If you text it to me, no, you don't have my cell phone number. If you send me an email or say it to me in person, you can get a treat from class, be the first person. Can I read out the first 8 for you? 1 is 30, 2 is 20, 3 is 30, 4 is 40, 5 is 5, 6 is 78, 7 is 81, and 8 is 70. Read off the next 4 as well. 80 is 9, 10 is 10, 11 is 40, and 12 is 60. Give you a couple more minutes. I'll come around and check, see if you got questions on any of those. That was good. Is it okay? Yeah. You have 3 seconds. Good.
Yeah.
Okay. Good?
Yeah.
Gina?
Yeah.
Thanks for supporting U of M today.
Oh, yeah.
So negative.
This one I
rotate
What did you
direction.
say?
So we're gonna go like this. So this would be negative 90. Or negative 10.
It says-
Oh, okay.
Yeah.
20 degrees.
Oh, no, number.
Questions?
When it's a negative, do you write the,
Reference angle, you always write the positive.
all right.
Yep, always. Two more minutes and we're gonna plug back into where you're at with your notes and the different homework piece. We had a crazy game of Pictionary today during our flex time.
I heard you guys yelling.
You did. Where's your flex?
Large shades.
Oh, so you're right next door there.
And Netzers.
Got it, yep. Boys finally beat the girls. Normally the boys do not beat the girls. So, actually, you have D lunch then?
No, I have C lunch. I heard you, I was walking to my flex and
Oh,
heard
okay,
you
I
guys
got
said
it.
back.
Okay, got it. I got you. Okay, please pause where you're at. What I want you to do now is turn to this spot in your notes. Okay, you should be able to flip like one spot forward to get to this spot in your notes, which is geometrical stuff. Okay, and then I also want you to turn in your homework. You're going to turn to the homework assignment that says terminal points. And you're going to get to the spot of your homework that has this big circle with a lot of empty spaces. Okay? You want to be on this spot right here. So you want to be in your notes and you want to be here. Everybody got that? All right. So, converting degrees to radians is something you're going to use for the rest of the year. Another thing you're going to use for the rest of the year is finding terminal points, which is what we're going to talk about today. In order to help you understand that better, we need you to be able to understand a little bit of geometry. Because if you look back at this piece right here, you can see that, in fact, a lot of our angles that we're using in trigonometry on the unit circle have to do with 30, 60, 90, 45, so on and so forth. And the big deal today is that this spot right here on the x-axis, we said that that coordinate is none other than 0, 1, and this coordinate up here is 0, 1. And that's pretty self-evident. Everybody agree? Okay, you could come up with those points, and this would be negative 1, 0. But the question is, what about this point right here? And what about this point over here? And what about this coordinate down there? What are those points? We call them terminal points, and we find them by first discovering the properties of our special right triangles. And the first we'll discuss is the 30, 60, 90. What makes a 30, 60, 90 great is that it is exactly half of a 60, 60, 60 triangle. What's special about a 60, 60, 60?
Equilateral.
Equilateral, which means
All the angles.
all the angles are the same and all the sides are the same, okay? So for example, if this was your triangle and this had a length of 10 on that side, then this side would also be a length of 10, and the side here would also be a length of 10. Everybody good? So, but we don't have a 60, 60, 60. We're going to cut that in half to get our 30, 60, 90 triangle. And when I cut it in half, all of a sudden, it lends me to some insight. If that side is 10, what is this side?
5.
It's 5. So we have one of the other sides. Does anybody remember from their geometry days what we do to find this side? You simply multiply it by the square root of 3. Works that way every single time. Every single time. I will quick show you why. Second hour really wanted to see this. Third hour kind of did. We'll see where you guys are at. But if you have a triangle that measures, this side is A, and this side is twice the value, so 2A, we want to find what B is. And if you just use the Pythagorean theorem, A squared plus B squared is equal to this thing squared, or 4A squared. Everybody with me on that? I will subtract the A squared and I get B squared is equal to 3A squared. Then I will square root both sides and I get B is equal to the perfect square you get to take out of 3A squared is none other than A. So you have A roots of 3. So in other words, if you ever have a 30, 60, 90, if this is A, this is twice that, and this value is A times the square root of 3 every single time. There's a proof for you. So what if we changed it? What if this had a length of 8? What would this side be? 16. What would this be?
8 roots of 3.
I mean, it could just be that simple. If you want to go through and do the Pythagorean theorem every single time, you can. Or you just write the square root of 3 next to it. Okay. The other kind of triangle we have is a 45, 45, 90. We call this the isosceles right triangle. What makes a triangle isosceles? Two sides are the same. We know that this side is the same and this side is the same. Okay? There we have it. So if I am given this is a length of 6, I know that this is also a length of 6. Does anybody remember what the hypotenuse is?
X squared root of 2.
You take this side and you multiply it by the root of 2. And we could do the same type of Pythagorean theorem proof in order to show that it is always, in fact, the square root of 2 that you multiply by. So you don't have to do the Pythagorean theorem every time. You can just trust it. Good. So suppose I changed it. Suppose instead of 6, suppose I had this side here was 7 roots of 2. What would this side be? 7 and 7. Okay, so you guys are pretty smart here. Suppose I changed it instead of 7 roots of 2. Suppose this was 5. What would this side be?
5.
To go from this side to this side, you multiply by square root of 2. So to go from this side to this side, you divide by the square root of 2. So this side would be 5 over the root of 2. And then you multiply top and bottom by the root of 2 to get 5 roots of 2 over 2. So a little bit different when you got that square root up there and you're trying to work with it. And then we have, again, another 30, 60, 90. I just tipped the shape. It still has the same properties as the other. No big deal. If this side is 17, what would be the length of the hypotenuse?
square root of 3 over 3.
34 is the length of the hypotenuse.
Oh,
And then the longer leg will simply be 17 times the root of 3. Those are our properties of our 30, 60, 90s and our 45, 45, 90s. Do you remember it?
Yeah.
Have you repressed it? Sometimes people come into class and mention geometry and they start to have like tremors in front of me. I'm like, you guys gotta slow down. You know what I mean? Some people have great memories of geometry. Some people don't always. So anyway, good for you guys. So these are the 4 examples we'll do. We're going to use the knowledge that we have about our special right triangles to be able to find the terminal points. So we want to find the terminal point for pi over 4. And what that means is if we have an angle that measures pi over 4, at what point does it cross on the coordinate plane? So this spot right here, we already said was 1, 0. And this spot was, in fact, 0, 1. How many degrees is pi over 4?
45.
It is 45 degrees. So the first step is to construct an angle that matches. This is a 45-degree angle. We then identify the reference angle. The reference angle is the angle formed against the x-axis, which is, in this case, 45. That allows us to create a special right triangle. And our special right triangle is a 45, 45, 90. Special right triangle, 45, 45, 90. Once we have that, we can go ahead and work to try to find that coordinate. Our goal is to find that coordinate. It's not 1, 0. It's not 0, 1. It's not a half. Okay, we'll figure out what it is. The fortunate piece of information that we know about this is since it's in the unit circle, the radius is 1. So what is going to be the length of this hypotenuse?
1.
Every single time, the length of that hypotenuse will be 1. Now remember, the work we did up above, if this is 1, what do we do to get this side? We divide by the square root of 2. 1 divided by the square root of 2. I don't leave the square root of 2 in the denominator. I multiply the top and bottom by the root of 2, and I get the root of 2 over 2. That is the bottom. The side will be the same length, root of 2 over 2. So this coordinate right here is this horizontal component right here. The side piece is the x value, root of 2 over 2. And then the y value is the root of 2 over 2. That is my coordinate. Let's try the next one. 4 pi over 3. How many degrees is 4 pi over 3? By times by 180 over pi. The pi's canceled. The 180 over 3 is 60 times 4 is 240. So I have a 240 degree angle. That is going to take me to the third quadrant. I'm in the third quadrant. I always draw my triangle back to the x-axis. And I identify the reference angle. The reference angle is the angle formed against the x-axis. What is that angle formed?
60.
Yep, 60, because if that's 180 and that's 240, then I have 60 right there. So this time I have a special triangle of 30, 60, 90. What is always the radius? 1. Once I have this hypotenuse, the longer side, what is the shorter side? it's going to be half of the longer side. So this will be half. So the shortest side is half the length of the hypotenuse. What do I do with the shorter side to get then the other side? I multiply by what? Square root of 3. So I take 1/2 and I multiply it by the square root of 3. If you multiply that, you can see that you get the square root of 3 over 2. And so this coordinate right there has an x value and a y value. The x value is going to be the 1/2, and the y value is going to be the square root of 3 over 2. Are they positive or negative?
Negative.
Why?
In the third quadrant.
In the third quadrant, so they are going to have negative values. Negative 1/2 and negative root of 3 over 2. Letter C says t is negative 5 pi over 6. Let's convert that to degrees. What is 5 pi over 6 in degrees?
150.
Yep, so I have negative 150 degrees. If I went positive 150, I would be in the second quadrant. But it's not a positive 150, it is negative 150, so I am in the third quadrant. I always draw my triangle back to the x-axis. What is the reference angle?
30.
30. So this is a 30, 60, 90 triangle. I always know that the hypotenuse is 1. Just like we said in the other scenario, the shorter side is going to be half of that, so it'll just be 1/2. And then the longer side will be times the root of 3 or the root of 3 over 2. That looks familiar, doesn't it? It just so happens that they switch locations. Half of your assignment today, okay, or half of your instruction happens right now. The other half of your instruction happens in the assignment. You're going to notice some patterns. If you notice some patterns like, you know what, I think I can do this quickly. That's what we want to have happen. Eventually, we want to be able to say 5 pi over 6, and you know right away that it's 150 degrees, and you know right away what the terminal point is. That would be helpful. Now, if you can't get there, that's fine. You can always draw the picture, but it would be helpful if you could get there. So this coordinate right there has an x value and a y value. The x value is negative root of 3 over 2, and the y value is negative 1/2. And our last one, negative pi over 2. What is negative pi over 2 in degrees?
Negative 90.
We have negative 90 degrees. As I draw that, the first reaction, because people get used to this process, is they always want to draw a triangle. And they go like this. That triangle doesn't help me at all. Because in the end, it's asking for the terminal point. The terminal point is simply this location where the angle crosses through the unit circle. We know that. What is that spot?
Negative 0, -1.
Yeah, 0, -1. So we don't need to do anything else. Like, that's just done. So if it ends up on the axis, that's going to be rather quick, isn't it? Okay. Good. Okay. So you already started the reference angles one. This terminal points one. Give you some time over the weekend to work on it. Super important. As you look at this piece right here, this is the third page of the assignment. Okay. The previous two are right here, where the drawings are there for you. You can quick draw them out and make the sketch and find the point. But eventually, you want to make your very own unit circle. The feedback, this is the fourth different way I've constructed this assignment. Feedback from students previous year, this is by far the most helpful way of doing this. And so you eventually then fill out this entire piece. You already have or that you can put down on your unit circle. And you should hopefully notice a pattern. So as you look at your unit circle, I'll show you how to fill in one of those so you kind of know what that space means and what it looks like. But we have on your circle, let's see here, we draw that. Let's go to the 45-degree spot right here. I think you guys have a coordinate that looks something like that, and then you have a space with a degree, and then you have a space right below it, something like that. Is that right? So what they're looking for is next to the degree, you write 45 degrees. Here, you write the radian. 45 degrees is the same as what?
Pi over 4.
So you write pi over 4 here. And then this is the terminal point. And we already decided that that was the root of 2 over 2 and the root of 2 over 2. You obviously know the one on top here, okay? It's the degree is 90 degrees. The radian is pi over 2, and the coordinate is just 0, 1. Like you have those pieces. You want to complete all those, okay? All right. You have about 10 minutes. I'm going to let you go. You can go ahead and work. I have the answer key up here, and I'll come around and help you. But you want to get started, try to knock out the first few, make sure it's making sense, okay? Look for patterns, look for patterns, look for patterns. Makes sense. Okay, oh, so this is the horizontal component. So the root of 3 over 2 goes here. 1 half of the vertical component. So it goes wide out here. So you just switch around. Makes sense? See the pattern?
Yep.
Makes sense?
How we doing? Good.
Yep.
Yeah.
So this is a 30-degree angle, okay? This is 1, and that's 30 degree. This can be a half. It's for the 45, and then with the root 2 over 2. This would be half of the 3 over 2, okay? It's 45 like here, then you end up with plus 2. If it's a 60 or 30, then you end up with 1. Yeah? Making sense?
Yeah.
So this would be a gradient then. So if you need to sketch negative 1.6 gradient, if you notice this is a 1.5 centimeters. So 1.6 would be like that, just a little bit past that mark. Negative 1.6 would go just past that. Yeah?
Yeah.
Better? Making sense? Okay.
Okay, I get like, because I do like numbers and stuff, right?
So that's one, so 210, 225.
Oh my God.
240.
Okay.
And then I would just start here, start producing these, and then transfer them over to the table.
Oh.
So if you do pi over 6, okay, let's just get you. Pi over 6 is 3 degrees, right? So 3 degrees. And then, so we know that, yep. So we know this is always 1.
Mhm.
The short side is going to be half. The long side is going to be. Oh, so root of 3 over 2. Good. So that means that this coordinate here then is the horizontal part, which is the root of 3 over 2. And the vertical part, which is 1/2.
So wait, how did we? Oh, I guess we just. How did the 2 get down?
So 1/2 you can write as 1 over 2 times the square root of 3. You write square root of 3 over 1. Multiply those against square root of 3. So your coordinate right there is root of 3 over 2 and 1/2.
Okay.
So then you can take that and just place it over here.
Okay.
You can continue on down that line. Make sense?
Gotcha. Yeah.
Yeah, so this is all right. The only thing I would just say is that just, you didn't make a mistake with it. Often people draw it into like that. You know, I'm coming back up here.
Oh, yeah. Yeah.
So you recognize that this is still the larger size of the cross.
Yeah. But just for the visual.
Yeah, so just as long as, you know, 60 degrees should be the bigger side and 30 degrees should be the smaller side.
Okay. Mr. Gans?
Yes.
What did you teach me that yesterday?
Yeah. Yep. Will you be bringing me back seashells?
Sure. We have the quiz Wednesday, right?
Yep, Lily is taking requests if people would like